let's see an example of making constraints more simple. So it's a puzzle from the speed setting competition, puzzle by DadJokes, and it has Kropki squares and border sum indexers. And border sum indexer goes as following. The first digit starting from the outside clue is the indexer of the border. Let's say border 1. Oh, I don't want given digits. Border 1. So it's this border. This one. So that's the second border, the third border, and it says that the digits around this indexed border sum to the to this value. So, for instance, if that's 1, then these digits will sum to 14. If that's, for instance, 5, then 1, 2, 3, 4, 5. That's border 5. These digits sum to 14, so they probably 6, 8 in this case. And if it's 9, that's this border, which means that just this cell equals to 14. So let's try to implement this one first. Do a custom constraint, call it border indexer. That's a local constraint, and we will just use the groups as usual. Border indexer. Border indexer at, and let's actually just make it shorter. Let's call it after the first cell only. It must be it. Okay, now we have the constraint, and now we have the groups. So let's add this one first. But now we face the case when it's not enough to just tell which cells the constraints applies to. We also need to tell somehow that it sums to 14. So that's exactly the purpose of this value field, which is completely optional, but we can use it like in the way that we want. So if we check what's inside this group now, so we have the array of cells and we have the value. Please pay attention that the value is always a string, not a number. So if you need a number, you need to manually convert it to it. So we know that except for the cells, we need to provide the sum and convert it to a number. And now we know that the regular constructor already doesn't apply, because we don't only provide the name, but we also provide the cells and the sum. And that's when these methods come to place. So the first of them is basically the constructor. It gets the instance, like some preparation for the object that we'll have, the component object, and it gets all parameters that we passed here except for the name. So let's say that we want sum and cells. So the purpose of the method is to just save these parameters into the object, and the second function that we need to implement is get affected cells. That also gets the arguments of the function except for the constraint name, which still like hard-coded to always be the first function argument, and we need to tell by all the arguments that we passed to the function which are actually the cells that we need to apply the constraint to. In this case, it's just this array. But it could be like we, let's say, implement a lookout line, so we will have one argument for the line ends and another arguments for the inner cells, and here we will need to like compose them into one array of cell IDs. And everything that we did here will be accessible in all other function. For instance, like update. So we have cells and we have sum. Let's check that we got it. Update. Here are the cells, and here is the sum, and we see that now it's a number because we did the conversion. We can remove this debugging statement. Usually there's no reason to implement the validation function if we can do everything in the update. So we will need it for the logical solver. Let's read the name as well. We always need that. So this constraint is a perfect example for component simplification. So let's read the value of the first cell, which is the index cell, and if it's already fulfilled, then we can know which are the affected cells. So I'm taking all the cells starting from index -1. The reason for -1 because the array is 0 based and the index is based on 1. The first index is the 1. So if the index cell is 1, then we need element 0 and element 1. So we slice 2 elements here, and we just tell puzzle replace component, and we could use something simple instead. So we have out of the box component for the sum. Let's see what it expects from us. So name, sum, and cells. Very easy. So name, sum, cells. And I usually just preserve the name of the original component, but we always can do something more specific and meaningful. But this one probably would be enough to brute force the puzzle. If knowing some value of one or more cells could simplify our component, we need to do it first thing. So let's check. 5. Here we go. It understood. It replaced our component by the sum component. It knows that these cells sum to 14, and it works. And if we, for instance, do... Oh, okay, so it could also do things by contradictions. So it knows that we cannot place 1 as an index because we will need 2 cells to sum to 14, and one of them is 1. We cannot place 2 as an index because, again, 2 cells summing to 14, one of them is a 3, and we cannot place 9 because it will sum only this cell to 14, and it's quite hard to sum one cell to 14. But usually when working on the logical solver implementation, it's better to disable the contradiction and check that your constraint could do some basic deductions by itself. Right now it cannot because we didn't implement anything except for the simplification. Let's check if brute force solver can find something. Yeah, quite easily. So now that we have the simplification, it's still not enough for the logical solving, and if we don't know, the brute force solver will still be slow if there are many clues. So, for instance, if we do something like that, it doesn't know that the puzzle is already broken. Let's actually try how much. Oh, okay, that was fast. But if there are many different constraints then it could be it could take much more time to do that. So the next thing that we could do is to actually implement some logic. So in case of such a constraint, probably the easier thing to do would be just go over all possible values of the index cell and check which of them are broken, like just brute force the thing. And there are cases when brute forcing inside of the update function is good. There are cases when it's bad. Basically, if we know that brute forcing is fast, then we probably should do that. And we just need to know like which cell needs to be brute forced. So in the case of this component, like the brute force solver could try placing many different digits here, and it will take time for it to understand that the puzzle is broken because nothing could fit this cell. So what we could do is like give a clue for the component that if brute forcing something, that probably this cell, because it's the most powerful one. So what we could do is just go over all possible values of the index cell and check which of them don't work. So we could use the same code for checking the indexed cells, and we can check if it's valid or not, I guess. So if we could probably check what are the candidates of these cells. Okay, so now we have the array of the candidates of the indexed cells. So what could we do to check? First of all, if index is 1, that it's a special case. So in this case, it's valid only if the second cell has a candidate of sum -1. Otherwise, if we have only one indexed cell, then it should contain the sum itself. Then we probably In the other case, we need to do something more complicated. So we can, I guess, go over the candidates of the first cell. You know what? Let's do it the readable way. Go over the candidates of the first cell. Check what is the second one should be for it to work. If it's less than mean digit, or it's greater than max digits, that it's already not what we wanted. Otherwise, if the second cell has this candidate, then probably it's valid, and we can stop checking. Something like that, I guess. So now we know if the index could work. So if it cannot work, then we could remove this candidate. Remove candidate from cell. Index first cell. I guess it should work. Let's check. Yeah, now we have the same that we had before. It's removing 1 from here, 9 from here, and a 2 as well. So that's already better. Now we can handle some of the edge cases. For instance, if the digits are the same, that they are not valid candidates, or if one of them equals to the index, that's also not a valid thing. Let's see if we have something new. No, but what I basically did is I said that, for instance, if that's a 5, then this one cannot be 5, 9. Actually, let's check that it works, right? Why not? So now 5 shouldn't be the valid candidate because it excludes 5, 9 from here. Boom. It works. Also, it sees that 7, 7 is also not a valid candidate for that, and that's exactly what we did. Now I guess I should add the rest of the groups. just in case. Oh, okay. That's one important thing that it's better to handle. Let's do it again. You see this message in the bottom? Error while updating custom constraint border index component. Cannot read properties of undefined blah blah blah. And the reason for that is that the code that we write here and the code that we write here basically runs each time when updating something in the puzzle. So in this case, we started to add a group, but we don't have a value. So it could be a nice thing to do some validation for these intermediate states. So if we don't have the value yet, then we can continue, or if the group has less than 9 cells. So now it should be all okay. Yeah, see, we don't have this error anymore.
Can I ask a question about the validation? So would it make sense to add validation that the value's not like greater than 17, for example, for someone who's like, if this was to be shared with other users? Possible value.
Basically, I called it validation, but basically we cannot display any warning in case it's something bad. We can just skip things when they don't work. So, like for instance, if you use one of the built-in constraints, then it gives this warning if the constraint is incomplete. Right now, it's not possible to do the same for the custom constraints. So even if you do validation for something that doesn't make sense, if it's not an intermediate, something like if the reason why we have this error is that I just didn't finish entering the input group, yeah, we can do the validation. But if someone intentionally writes something that doesn't make sense, we cannot really do something with that because we cannot give any feedback about that.
Okay, thanks.